Here's another example. What's happening is that there is a block, there's a bob attached to a block, to a string of length L. It makes an angle theta in the beginning. There's a second one that is that's at rest. They both start at rest. So this is at rest here. The second bob is also at rest. The bob one swings down, and then after it collides, they stick together, and then they move as one giant bob. And the question is, what is the angle that they make in the end? Okay, so we've been told that it starts with an angle of 60 degrees, and our goal is to find the final angle, the final maximum angle that it makes. So once again, this problem involves three different things, just like the previous one. It involves the bob swinging down. For that, we will use mechanical energy conservation. Then it involves a collision. Things get stuck together, so it's a perfectly inelastic collision, which means you can use Pi equals Pf. And then they swing up, for which again we will use mechanical energy conservation. So you'll see that the pattern becomes fairly straightforward in all these problems. So let us do the first part. So the first part is the swing down for the block 1. So for the swing down, we will use MEI equals MEF. Okay. Now to use MEI equals MEF, we're going to use again the kinetic energy of bob 1, which is 0 because it's at rest, plus its potential energy. And its potential energy is going to be mg times, if you remember, this is the height drop is simply L times 1 by cosine of the angle. Okay, so this should be standard by now. Like, you should recognize this right away, should be able to do basic geometry and figure this out. Just do it a couple times and you'll never forget it. And then at the bottom, it has all kinetic when I have mv square plus 0 potential. So this is only for bob 1. Now cosine of 60 is half, so I get mgl times 1 minus half equals 1/2 mv square. Now 1 minus half is nothing but half. The half cancels out, and v is equal to square root of gl. Great. So we have the velocity of bob 1 just before the collision. Okay. So now we are ready to figure out what happens in the collision. And the collision, the two bobs, they meet. Okay, so this is moving with speed square root gl. The other one is at rest, and they're going to move as one giant bob. Okay, so let's figure out. We're going to use pi equals pf. Let's figure out the velocity right after the collision. So in the beginning, only one is moving, so it is m times square root gl plus m times 0 because second bob is at rest. And in the end, they're moving together. So it is m plus m times some Vf. Great. So Vf now is equal to square root of GL divided by 2. If you do the algebra, you'll see the two m's. We get 2m out here, and that'll cancel one of the m's. The m's goes away, and then I'll simply have 2 left. Great. We're done with part 2. Now the part 3 is the swing up. Okay, so for the swing up, once again we're going to use mechanical energy conservation. Use MEI equals MEF, and when we do that, what we have is we have at the bottom only kinetic energy, so it is 1/2 times 2m times square root GL over 2 the whole square plus no potential. At the end, what's going on? At the end, what's going on? No kinetic and all potential. So it is 2mg times let's just call the height h first, okay, and then we can figure out the angle once we know the height h. It's easier to do it that way. Now the half and the 2 cancel out. We have m times gl over 4 on the left hand side, and it is equal to 2mg times h. Now the 2 and the 4, that becomes an 8. The m cancels out, the g cancels out, so h is equal to L divided by 8. Great. Now that we have h, we know that h is equal to L times 1 minus cosine of theta again. So just to give you a quick review, this is what happens. This is the height h, this is the angle theta, this is L, this whole thing is L, and this thing is L cosine theta. So h is L minus L cosine theta, And now what we know is that L over 8 is equal to L times 1 minus cosine of theta, and what we get is 1 minus cosine theta is equal to 1 over 8, which implies that cosine of theta is equal to 7 over 8. And now you can get the angle theta as cosine inverse of 7 over 8, and that's our answer. Okay, so once again in this problem we used three things. For the swing down, where is it? For the swing down we used MEI equals MEF. For the collision we use PI equals PF, and this for the swing up we can use MEI equals MEF once again. Now in other situations, if something's swinging down and sliding on a rough surface, then we can use WNC equals MEF minus MEI, but it's the same concept, the stuff that you've used time and again. Okay, so hope that makes sense.